Alright, we're going to look at factoring two terms. We've done four terms with grouping, three terms with the diamond problem, and then grouping. Now we're going to look at two terms. First, let's do some warm-ups and a little bit of review. Factor completely. 2x squared plus 7x minus 4. Is there a GCF? Nope. So we multiply the a and the c. 2 times -4 and it's -8. And the middle term, b, is 7. So we want two numbers that multiply to -8 and add up to 7. So it's 8 and -1. So we split up that middle term, 7x, into those two. So 8x and -1x. And again, you can always go backwards. 8x plus -1x is 7x. We can always go backwards and make sure that we're doing it right. So we can take a 2x out of this first group. We're left with x plus 4 when we divide it out. And here, we can't take out any numbers except for -1. This first term's negative, so we divide by -1. We get a positive x, and -4 divided by -1 is positive 4, and these two are the same. That's what we want. They have to be the same, or else we made a mistake. These need to be the same. So we take those out. Oh, it's x plus 4, not 2x. And then we have leftovers 2x minus 1 in the other set of parentheses. So there's my factoring. Letter B, GCF, 9 and 16, nope. Multiply the a and the c. 9 times -16 is -144. Our b is 0. So we can rewrite it as 9x squared plus 0x minus 16. Or it's our x term that's missing. That's our b term. So that's 0. So what two numbers multiply to -144 and add up to 0? Well, if they add up to 0, they have to be the same, but one's negative, one's positive. And something times itself is 144 is 12. So -12 and 12. So we split up that 0x into -12x and 12x, which we can always go backwards. Add those two, they cancel out. We get 0x, which is really 9x squared minus 16. This time I'm going to do the box. 9x squared, 12x, -12x, -16. Out of these two, I can take a 4. Out of these two, I can take 3x. Out of these two, I can take 3x. Out of these two, I can take -4 because the first number is negative. So we get 3x plus 4 and 3x minus 4. Again, they should look familiar. They're kind of like conjugates. And we'll see more about those in a second. Letter C, is there a GCF? Yes, there is. We take out a 5. So when we divide out by 5, we have x squared minus 10x plus 24 left. So we do a diamond problem. Remember, this is 1 times 24, so 24. And the middle number is -10. So what two numbers multiply to 24 and add up to -10? -6 and -4. So we split up that -10x into those two terms. So it's x squared minus 6x minus 4x plus 24. So we can do the box, or we can do grouping. Either way, don't forget your GCF. So it's 5 times x minus 6 and x minus 4. So just a little bit of review. Now, two terms. There's two different ways we can have two terms. First thing we always do is check for GCF. Always. Then, if it's subtraction, and the two terms are perfect squares, we have difference of squares. They're like conjugates. So a squared minus b squared is really a squared minus b squared. Squared means 2, so it means we have a twice and b twice. And difference of squares, well, difference means different signs, minus and positive. And we'll look more about that in a second. If we're factoring two terms, again, we look for a GCF. Now it can be subtraction or addition. And if it's either one of those and the two terms are perfect cubes, something times itself 3 times. So a cubed plus or minus b cubed, it could be either. So then it'd be a cubed plus or minus b cubed. Then it equals that same thing without the cubes. So if this was plus and this was plus, then the first one is we square this first one, a squared. We do the opposite sign. We multiply the two. It's always positive, and we square the last. So that's this acronym, binomial, or B-SOFAs. And we'll see that more with our problem. So let's do some problems. So 25x squared minus 4. Is there a GCF? No. Is it subtraction? Yep. Are they perfect squares? Yes. 25x squared is 5x squared, and 4 is 2 squared. So squared means 2. So I'm going to write 5x and 5x in both of them, and 2 in both of them. And it's a difference of squares, so one's plus, one's minus. And that's it. And the reason that we only have 2 terms and not 3 is we're missing that middle term, because when we multiply, the middle term cancels out because these are opposite, just like when we had conjugates. We multiplied by the conjugate, so the middle terms would cancel out. It's the same idea. Now look at this next one, 16x squared plus 9. Is there a GCF? No. It's addition. So if it's addition, only if they're cubes can we go farther. Are they cubes? Is 16x squared something cubed? No. So it's prime. Because this was subtraction, we couldn't do what we just did there. If it was subtraction, then we could do a difference of squares. But difference of squares means it's subtraction of square numbers. And this was addition of square numbers. So not what we're looking for. Then 27x cubed minus y cubed, is there a GCF? No. Subtraction, okay. Are they cubes? Is 27x cubed something cubed? Yes. 3 times 3 times 3 is 27, and x times itself 3 times is x cubed. And of course, y cubed is y cubed. So I rewrote them like that. It's subtraction, and it doesn't matter that it's subtraction. It could be addition. It doesn't matter with cubes. So our B sofas. B is binomial, meaning we write this same thing without the cubes. We kind of ignore that and we ignore that. So it's 3x minus y. Then S, square the first term. So this is our first term. This is our second term. So we square the first term. 3x squared is, well, we square the 3, 9, and x squared is x squared. O is opposite sign. In the problem it was a minus. So we do positive, because we use the opposite sign. Then F is first times last, so 3x times y, 3xy. A, always positive. This sign is always going to be a plus sign. And then S, square the second. Well, y squared is just y squared. So we have this as B sofas. That's our difference of cubes. All right, the next one here, is there a GCF? Yes, there's 6. So we take out, 6x. Take out 6x. We're left with x cubed minus 64. Subtraction, okay. Is it cubes? It is. It could have been squares, and we could have done difference of squares if it was squared, but it's not. So it's cubes, so x cubed is x cubed, and 64 is 4 cubed. So we do our B sofas again, and we don't forget our GCF. Notice, just rewrote it, the GCF there. Then binomial is the same thing as what we wrote here, without the cubes. So x minus 4, this is our first term, this is our second. So S, we square the first, x squared is x squared. O, opposite sign, it was minus, so now it's addition, it's plus. F is first times second, so x times 4, so 4x. A, always positive. And the last S is square again, but now we're squaring the second thing, so 4 squared is 16. So we have 6x, x minus 4, x squared plus 4x plus 16. So we have 3 parts to it. Got a lot going on there. All right, next one, x cubed plus 25. Is there a GCF? No, it's addition. Okay, so now it has to be cubes or else we can't do it. We can't do it if it's squares and addition, we can't do it. We saw that up here. But they are cubes. X cubed is x cubed. 5 cubed is 125. So we do our B sofas again. Our binomial is the same thing without the 3's, so x plus 5. Then we have our first and second terms. S is square the first, x squared is x squared. Opposite sign, it was plus, so we do minus. F is first times second. X times 5 is 5x. A, always positive. And S is square of the second. So 5 squared, 25. So that's our answer, both parts. So sum and difference of cubes, we're always going to have a binomial and a trinomial. When we have difference of squares, we're going to have a binomial and a binomial. All right, this one. Is there a GCF? Yep, we take out 5x. And now there's no x squareds to break down. So we can't factor it anymore. So we're done. It's just 5x times x minus 4. We can't break it down anymore. All right, the pink problem here, 9x squared minus 16. Is there a GCF? No, there's not. Subtraction. Okay, squares. Yep. 9x squared is 3x squared, and 16 is 4 squared, and it is subtraction. So, squared means 2. We write 3x twice. We write 4 twice. And difference of squares, so we have different signs. One's minus, one's plus. And 3x minus 4, 3x plus 4. And again, notice that is the same thing as our warm-up b here with b term of 0. So you can do it this way with the diamond problem, or you can do it with the difference of squares, which I think is a little bit shorter. Last, x to the fourth minus 16. Is there a GCF? No, there's not. It is subtraction. Is it squares? Yes. X to the fourth, so now think about it this way. Can we take the square root of x to the fourth? Yes, we can. We have two pairs of x's, so we bring it out. And so it's x squared squared. It's a little bit different, kind of weird, but that's something squared. And 16, of course, is 4 squared, and it is subtraction. So we do our difference of squares. Write x squared twice. We write 4 twice. And then we do 1 minus, 1 plus. Now, we still have x squareds. So x squared plus 4, well, because it's plus, it can't be a difference of squares, so we can't go any farther with that. But x squared minus 4, it is a difference, it's subtraction, and it is something squared still. X squared is x squared, and 4 is 2 squared. So we write x, and 2, and 1's minus, 1's plus, and we still have the other part. So we have 3 parts to this. So we got to keep going. That's why whenever it says factor completely. So a lot of work, but you guys will figure this out.